In this video, we'll be talking about identifying the constant of proportionality or rate of change in graphs and tables. What is a constant of proportionality? The constant of proportionality is how much one unit changes for every one of the other unit. How much y on the graph will change for every one of the x, y over x. This is also called rate of change. For instance, if I have to identify the constant of proportionality in the graph, I have to look at the y-axis, and that will be my numerator, and then x-axis will be the denominator. We'll label the constant of proportionality k, and we're going to say that this is the change of y over x. From the graph, for the one unit here on the x-axis, I have 20, so in between should be 10, 20, 30 for the y-axis, over 1 for the x-axis. So y over x, 30 over 1, and that's the distance in miles. For every 30 miles, we have inches. So actual distance in miles and inches on the map. For every 30 miles, there is 1 inch on the map. Constant of proportionality, 30 to 1. In the second graph, we have paper and box. How many pieces of paper are in the box? So let's say the y values over x values represent pieces of paper in the box. So constant of proportionality is relationship of paper per how many boxes. In the chart, I can see 0, 0, 50 over 4. So I'm using y over x, 50 over 4. Then, how many pieces of paper will be in one box? Divide by 4. And it looks like it's 12.5 per one. Constant of proportionality. From the chart, if I need to identify the constant of proportionality from the table or chart, I still use the relationship y over x. So k will be the y values over x. In this chart, I already have 50 over 1. So that is my constant of proportionality. The y will be miles. The x is hours. So that means my constant of proportionality is 50 miles per hour. In the next chart, I have cans of paint X and birdhouses painted Y. The constant of proportionality is a relationship of Y over X. In other words, birdhouses, if I can paint 15 birdhouses using 5 cans of paint, then how many birdhouses can I paint with 1? Divide by 5. 15 divided by 5 is 3. So I can paint 3 birdhouses with 1 can of paint. At this point, if you think you can move on without my help, you can pause the video and self-check or move along with me. Let's look at a few more examples. Constant of proportionality in graphs on the left-hand side, constant of proportionality in tables on the right. So let's look at these examples. The y values and the x values in the chart, I have 20 per 4 number of cups, it doesn't say, maybe flour, and sugar in pounds. So I have 20 over 4, 40 over 8, 60 per 12. The question is, how many per 1? So constant of proportionality is the relationship y over x, where on the y-axis I have number of cups, so I'll use this point right here, 20, and sugar in pounds, 4. So if for 20 I have 4, question is how much per 1? Divide by 4 and that'll be 5. 5 over 1. Price in cents per pounds. So how many cents is the y over x per pound? Cents per pound. Constant of proportionality is y over x. If I use this point right here, 20 over 2, then how many cents per 1 pound? Divide by 2 and that will be 10. 10 cents per pound. Constant of proportionality or unit rate or rate of change, 10 cents per pound. The distance in feet and time of the speed over sloth. Here we have already the constant of proportionality, 6 over 1. By looking at the scale and using the y over x relationship, I have 6 per 1 feet over time. 6 feet per minute. Hiking distance, we have distance in miles over time, y over x. I can look at my graph and use any of the given points to identify the constant of proportionality. So I'm going to use, let's see what the scale is. 4.5 should be 2. That means every square is 2. 2, 4, 6 per 5. So this point right here will be 6 miles per hour. Per 5 hours, I'm sorry. If 6 miles are hiked in 5 hours, the question is how many per 1? 6 divided by 5 is 1.2 miles per hour. Let's look at some charts. From the table of values, we use the same ratio to identify the constant of proportionality, y over x. Pages read in the number of days. 100 pages over 1 is already showing the ratio of pages per day. How many pages per day? 100 over 1. K, constant of proportionality, is the y relationship over x. From the chart, that is distance over time. So 90 over 2, if it's 90 distance for 2 time, what would be the distance for 1? Divide by 2, and that would be 45 over 1. Whatever the distance may be, given in feet, inches, miles, for time, whatever it may be, second, minute, hour, doesn't say. So distance over time, 45 per 1. Next chart, miles is the y, x is the hours, so it's miles per hour. From the chart, if we have 48 miles in 4 hours, how many would be in 1? Divide by 4 and be 12. Constant of proportionality, 12 miles per hour. Cups of sugar being the x and cups of flour being the y. To identify the constant of proportionality, we use y over x. In other words, cups of flour per sugar. If we use 5 cups of flour for every 2 cups of sugar, how much flour will be used for 1? Unit rate. 5 divided by 2, 2.5. So 2.5 cups of flour for every 1 cup of sugar. That's our rate of change, constant of proportionality, or unit rate. Votes, we have 2 people, Faye and Victor. So the constant of proportionality is the change of y, or how much is 1 unit relating to x, the other. These numbers are all mixed up, so you can use any of the numbers from the chart. I'll use the smallest ones. So for every y, meaning votes for Victor, 114, will be 3 the x votes for Faye. How many votes will be per 1? 114 divided by 3 is 38. So the ratio 38 votes for Victor to every 1